Good late morning. Sorry for the short coffee break, but if it felt not so easy to be between you and the coffee, then it's even a bigger challenge to be between you and the lunch. What I can promise for it is a very interesting session which completes this picture on set plan, namely taking up the third pillar, which is the supply of energy, which should be secure, cost-effective, clean and competitive. Now, what plays a big role is the way we generate energy and the sustainability of our system, which will be in the center of this third session on the energy system and how set plan is picking it up. Just a very few numbers to remind you. 80% of Europe's energy system still relies on fossil fuels, and this energy sector is responsible, again, 80% for the entire greenhouse gas emissions of the European Union. So decarbonizing is the core issue in a clean supply of energy. Also, just to remember, we are importing a big percentage, a significant percentage of our fuel in the form of fossil fuels from abroad. 53% of the energy we consume we are importing, and we spend 3% of our GDP for this import. We spend, as you heard several times, €1 billion per day for these energy imports. So the security of supply is key. Some estimates are telling us that it's possible that by 2050, all the fossil fuels which we will still need to import, I hope that won't be much, but that fossil energy, what we will be using, will be imported. So our renewable energy sector must be made more robust, and this is also a big issue in big part of this third session today. We must find the ways we can invest into them, and we must find the ways we can invest in the entire supply chain of technology. And also, we must find a way to further mitigate our dependence on foreign technologies. So as much as possible, we must diversify and use indigenous technologies. This late morning, we will have the opportunity to hear 3 concrete examples from both industry and research perspective. And these examples will show you how research and innovation can deliver tangible results, tangible solutions to address these challenges I was speaking about. We will have this morning 3 speakers in the debate. The first one will be Satu Helynen, the Vice President of VTT, responsible for smart industry and energy systems. Our second speaker will be Grim Sweeney, Chairman of the Advisory Council of the technology platform ZEP, Zero Emission Platform. And the third one, Ana Raquel Diaz, Director of Technology Strategy of the company Abengoa. So, to start with, I would give the floor to Dr. Helynen. Please do your presentation on the first issue.
Thank you so much. Good afternoon, and thank you for a possibility to give an overview on bioenergy and especially on research of it. I come from VTT, Technical Research Center of Finland, and we are together more than 500 experts working with energy supply and energy efficiency technologies and also on energy system analysis. And in my presentation, okay, once more, okay. Now I get the outline of my presentation. So I will start with the role of bioenergy in the energy system. And then I will describe how industrial value chains are transforming and how this has effect on the competitiveness of bioenergy. And then I present as an example Thermochemical conversion platform to produce bioenergy for heat, power, and biofuels. And then as a summary, prerequisites for how to commercialize faster new technologies in the field of bioenergy. Bioenergy has a very important role within primary energy production. And here are examples on 5 Northern European countries. And in Denmark, in Finland, in Sweden, bioenergy is the most important renewable energy source when looking at primary energy. In Iceland, it's geothermal energy, and in Norway, it's hydro energy. And we have in EU-wide potential even double the use of bioenergy by 2020 and triple by 2030. Of course, it's not such tenfold like wind or 100-fold like solar, but it's a very large potential to be developed. Here are scenarios carried out by VTT and other research institutes as a background study for decision makers in Finland. And we analyzed what should be the role, or what could be the role of renewable energy sources when we are targeting to those deep reductions of greenhouse gases by 2050. And we could see that in Finland, in each of those scenarios which we analyzed, the role of bioenergy is very, very important. Important as a renewable energy source, but also important as an integrator of intermittent renewable energy sources to energy system. And bioenergy sources are very versatile in Finland. It's not only wood and its residues, it's also agrobiomass, it's renewable waste, and to some extent possible also imported bioliquids. And the use of bioenergy, it will be both in heating sector, producing combined heat and power for cities and for industries, and also more and more in the transportation sector where liquid biofuels are used. And in case of Finland, the largest amount of use were drop-in fuels which can be implemented using existing technologies and existing transportation fleets. And here are examples of changing industrial value chains for wood-based raw materials. Wood-based bioenergy, it's an essential element of bioeconomy, and bioeconomy is one essential part of low-carbon economy we are targeting. But there can be seen very many changes in the future, and we have to try to find the most relevant value chains where the bioenergy production is most competitive. So biomass is used not only for energy and forest-based products, pulp, paper. It's used also for green chemicals, liquid biofuels, and in the future for green packaging and other type of green smart materials, plastics, biocomposites. And also for agricultural sector, we have to find the right type of industrial value chains, how to make the bioenergy the most competitive in order to go towards low carbon economy. And also in waste sector, there are several new type of industrial value chains where bioenergy can be produced. Here is an example from Sweden and Finland, where we are integrated both raw material harvesting to paper and pulp mills and sawmills, and it is integrated to harvesting and how to arrange logistics and storing for bioenergy, where we can use stumps, logging residues, and small trees from our thinnings. So the costs can be minimized or optimized when those sectors are integrated. And here are thermochemical conversion platform, which can be used for the integrated production of bioenergy, fuels, and chemicals. And this platform, it can be coupled with biological platform for biomass and also for chemical platform. And the products, they are power, heat, cooling, and the products can be upgraded to gasoline, diesel, jet fuels, and other bioproducts. So combustion, fast pyrolysis, and gasification are those most important processes for that. And here is an example of commercializing process which has very many steps, and it takes tens of years. Here are development steps for fluidized bed combustion from small scale to utility scale. And it is not only capacity increase, it's also improving efficiency, power to heat ratios in combined heat and power plants. And now this technology, it allows to use as much as biomass is available to replace, for instance, local coal resources with very high efficiency. And here are examples of recent demonstration project from the last 5 years. There are gasifiers from 50 to 80 to 140 megawatt with thermal power, which replace natural gas, coal, or oil, and also demonstration of production of fast pyrolysis integrated to existing combined heat and power plant to get those integration benefits. And all these have common that European or national or both demonstration subsidies or incentives are required, and also cooperation of utilities, manufacturers, biomass suppliers, and also research and development are needed. All those. So as a conclusion, so in order to get commercialization faster and more cost competitive in the field of bioenergy, so it's very important to look the whole industrial value chain, where the production of bioenergy is most competitive. It's not everything, it's one product of those value chains. And also the role of bioenergy can be different in different energy systems in different countries, if it is local or imported biomass, and also when we are looking at the cascading use of biomass. And that close operation with different type of stakeholders are needed, all those research development phases. So it is needed long-term commitment and critical mass of research activities. And companies are needed for the whole value chains being together. And also public sector, all those standards, permissions, incentives, they are very crucial. And also other stakeholders like consumers, other type of organizations, they have to be also involved in demonstration. And so I think if I have to pick one thing what is the most crucial, it is that the public risk funding for those large demonstration and flagships, it's needed. It needs on European level and national level, and we should learn from the experiences of NER 300. Thank you for your attention.
Thank you very much, Dr. Helynen. Thank you for this comprehensive and to the point overview. Maybe one element I would like to add, and where the European Commission is very active now, we cannot take for granted that we will have biomass in any quantities forever. So it's worth looking into it, what is the real availability in Europe of biomass, and what are the opportunities even for importing it. And for this purpose, quite a number of DGs in the Commission have made a kind of alliance to work out, to study, with the help of the Joint Research Center actually, to see what is the real potential, real availability, because indeed the most important source for the time being of renewable energies is the biomass, bioenergy.